Good morning. Today we are studying about a classical free electron theory. Before going to classical free electron theory, just we have to study about, just we have to take some points about the free electron theory. Here, in free electron theory, it gives nothing but the electrical and thermal properties of the metal. Here, they introduced the classical free electron theory, where the valence electrons are the responsible for the conductivity. And by improving the drawbacks of this classical free electron theory, the Sommerfeld introduced the quantum free electron theory, and he explained the conductivity and the thermal properties by using Fermi electrons. Now, this is the classical free electron theory. There are some postulates of the classical free electron theory. Here, both the two scientists, Drude and Lorentz, they introduced this classical free electron theory, and he proposed that all the metals which are consist of a free electron, that's the valency electron. The solids which having the valency free electron, they are nothing but metal. And here, all the valency electrons, see what is meant by valency electron. You have to see here, from this diagram, let us consider is a nucleus, and around this nucleus, the electrons will be revolving. These are the orbits of the atom. See here, the electrons will be present here. These are known as the valency electron. And whatever means, this outermost orbit is nothing but the valency electron. Here, every orbit there is a, depending upon the Pauli's principle, there is some electrons will be arranged. And the electrons which are present in the outer shell, that is nothing but valency electron. They are the responsible for the electric conductivity and thermal properties of the metal. And if you observe that, as this is the nucleus is always attract with electrons because they are the positive and negative charge. As the distance from this nucleus increases, means the distance between the nucleus and the valence cell is more. So the influence of the nucleus and the valence electrons is very less. If we apply a little bit energy, then what happens? These electrons are escaped from this atomic structure and they become free. If you consider a metal piece, these electrons are free from the atom and they will be free electrons. These are not the valence electrons. They will be moved randomly because there is no constraint, so they will be moved in different directions. In this the path, and in the path of this moving, what happens? It collides with the electron and the positive particles and other ions. And this electron obeys the Maxwell distribution law and also obeys the kinetic theory of gas. So they acquire the energy 3/2 kT. Where K is the Boltzmann constant, is the absolute temperature. But we know that from the classical theory, from Newton mechanics, we know that kinetic energy is equal to half mv square. Of m Okay? Kinetic theory, from the kinetic theory, it is equal to of mv square. Okay? Which is equal to 3 by 2 k. If you comparing these two energies, both are kinetic, so to cancel, so we get v square is equal to 3 kt by m. Now the velocity v is equal to, this is the random velocity where the electrons moves toward this a metal piece. That is, the v is equal to root over 3 kt by m. Where k is the Boltzmann constant, is absolute temperature, and here the m indicates the mass of the electron. See here, this classical theory it is already we discussed about this classical theory, and here we clearly observe that the electrons moves within the metal and the subject to collides with the positive ions of the crystal lattice. And these electrons obey the Boltzmann law, Maxwell-Boltzmann distribution law, and obey the kinetic theory of gas. They are some postulates of this classical free electron theory. Similarly, they have some merits and demerits of this classical free electron theory. They are mainly from this theory. There is a two main demerits. From this classical theory, you cannot explain, you cannot give the correct explanation of the photoelectric effect, Compton effect, and Planck's black body radiation, radiation of black body radiation. And also you cannot identify you cannot give the clear identification of these insulators and conductors. Okay. From this, you can observe that from this classical theory, they clearly explain about the specific means the electrical properties of the metals only. It does not give any idea clue for the insulators and other materials. Okay. From this class, we can we had shared about the postulates of classical electron theory. And next class we go for this quantum free electron